Okay, so this is a simple buffer overflow tutorial using this function right here, or this code, I suppose. The target function is going to be this f function. We're going to have this buffer unchecked and allow an overflow into it that will call the entry point address of this function and then print these two things to confirm that we were in that function. So to get started, we need to compile with f no stack. And I've already done this. I already have the file, the executable, already compiled. But when it's just going to look something like gcc minus fno minus stack minus protector. And when we compile it with that, it will not check for stack smashing. If you don't have this on, most GCC compilers nowadays will by default check for stack smashing. So make sure that you compile it without that if you're going to do this. Okay, so let's run it with GDB. So first thing we want to do is set our arguments. The way that this works is it takes the first argument after the first command line argument and uses that as the input for f, which is just a string. So if we say that our command line argument is this, so let's copy this over here. Basically what this is saying is it's giving a Perl script, and because it's got this little tilde here, it's emboxed in this tilde, it's going to execute this instead of just putting it in as a string. So this is saying set args of this executable, which is a Perl. This minus e is basically just echo for Perl. So it's saying echo print of the letter A 14 times, and then print this string right here. This string is going to be the return or the entry point address for the TBD function, which is our target function. That I'll explain how to know that, how to figure this out later, but for now I just have already done it. Yeah, so we're going to set the arguments to that. This first part, the print a times 14, is what's going to cause the buffer overflow. So currently our buffer is 6. Anything after 6 A's is going to be technically a buffer overflow, and since we're not checking for buffer overflows, nothing will get tripped up and we'll be able to continue through like normal, but these A's will bleed in to other points in the stack pointer, and I'll show that. Okay, so first thing we want to do after that is break at f, and this is basically saying B is shorthand for break in GDB, f is the function, so we're saying break at function f. And when we do that, it's going to give us this very short address. This is like the address before the operating system sets it into virtual memory. So this address isn't correct once the program starts, but for the breakpoint you can set the breakpoint because GDB will just automatically calculate it, or however it does it. Okay, so after that we want to run the function, and then it will stop at f, and you can see right here the breakpoint which we set for this has now changed to this longer breakpoint. Okay, so from there I'm going to run x/48b and then call the stack pointer RSP register. I couldn't think of what it was called. This is just the stack point register, 48 bytes of the stack pointer register. For some reason, for me, whenever I would do this, it would print out the 48 bytes in decimal, but if you continue after this, it will print them in hex, So I'm just printing it right here. You don't really need to do this early if you don't have them print in decimal, but since I do, it's much easier to see once they're in hex. So anyways, now that we've done that, let's do disass f, and this is going to show us the assembler code for function f and the memory locations for each call. So this leave right here is what we're going to want to set a breakpoint at. So I'm going to copy this and then set a breakpoint for that. Make sure to have this star here so that way it dereferences it. And there we go. Now we got a breakpoint at this leave part. We want to have that breakpoint there so that way we can check the stack pointer register and see how many A's we need to print, and I'll explain that more once we get there. But before that, let's check out the disass for TBD. So what we want to see here, this function here. This is our target function. This first line here, I don't know if that's hard to see. This is our entry point. So we essentially, what we're gonna do, and I'll continue and then talk about it. C is for continue, by the way. So now we're at the leave point in F because we set that breakpoint earlier. So if we call this function again, oh it didn't. Okay, so I don't know what happened there, but for some reason it didn't print out the hex again, which is really annoying. But anyways, so what we have here is the stack pointer at, I guess I can pull this up. This is the stack pointer at this breakpoint here, which is the leave function. And if we look at this, you'll see a bunch of 41s. And this is literally the A's that we printed from the Perl command. So capital A is 41 in hex for ASCII. So this would be, your regular buffer would have 1, 2, 3, 4, 5, and then this should be a null terminated string, so it should be null here, but we can have it be 6. And then this next line, there's 8 A's after this. So we've basically taken this whole thing here and filled it with A's. And then since we've done that, this line right here is kind of our target line. This is what we're going to be returning to. So whatever is in this point here, whatever address this is where we're going to return to. So if this was like the address for, say, the TBD function, which it happens to be the case it is, we're going to literally return into this TBD function and we're going to execute the TBD function. So then I guess to go into a little bit more detail, I'll show how this number is brought about. So like I said, this is the entry point for TBD. So essentially what I did to figure out how many A's and then what this value is this value should be the same every time. Whenever you run the function, you're just gonna go in, run disass on whatever function you want to enter, and then whatever the entry point address is, that's what you're gonna have after you've overflown into the return register, or into the return command instruction. The tricky part is you have to get to the return instruction and have it overflow up to that point. So what we put before the return instruction doesn't really matter. We don't really care about that. We're just trying to get into this TBD function. So all we care about is putting filler up until this point, and then at this point we want this to match the entry address for this TBD function. So we've done that. This will just take trial and error. You'll need to see like how many just try a random amount, see how many more or less A's or whatever you're inputting is, and then match it to get to the point where the next thing you input will be for this return instruction. And then once you get to there, it's really simple. You just copy this directly, have it set in as bytes or printed as bytes, and then once we do that, so I've already set it up so that the stack pointer has the return address of TBD in there. So then if we just continue, we'll see all those moments will be lost in time, like tears in the rain, time to die. And if you see in this function in main, it's never called. TBD is never called in main, yet we still get these function or these commands to print. So we've clearly had a buffer overflow. And that's also evident by the segmentation fault, because I would assume that once it gets done with TBD, this will have some random return address that was not in the memory location that was allocated, so it'll throw an error. But still, we did what we wanted to do. We got this function called. So yeah, that's basically everything about this buffer overflow tutorial.